At the moment, the only way we know to reach space is through rockets, but alternative methods might exist. Could we, for example, build an elevator that takes us into orbit simply by pressing a button? Let's try to figure it out. To reach space, a lot of energy is needed. The only method we currently know is to launch a rocket at a very high speed, but a significant amount of fuel is required to lift a rocket to the right speed to enter Earth's orbit or even to travel towards other planets. Someone might ask, why don't we ascend gradually, bit by bit, instead of starting off so fast? Well, basically, we have nothing to hold on to. Earth's atmosphere is dense enough to allow an airplane to stay in flight, but not dense enough for it to push its way into space. This is why rockets need all that fuel. They don't fly like an airplane, but instead expel a large mass at high speed, taking advantage of the conservation of momentum. Okay, but what if we built a very tall structure to climb gradually until we reached space? Such an idea, it seems, first occurred to Konstantin Tsiolkovsky in 1895. The name Tsiolkovsky should remind you of the Russian space pioneer who, among other things, formulated the rocket equation that I've talked about in another instance. It seems Tsiolkovsky was inspired by the Eiffel Tower, which had been recently constructed, and came up with this idea of building a tower so tall that it would reach beyond Earth's atmosphere. How could such a tower be constructed? To understand this, we need to use a concept, namely the formula for the orbital velocity of an object around the Earth. The speed necessary to stay in orbit depends on altitude. The higher you go, the lower the speed. Now, we could ask ourselves this question. At what altitude would we need to position ourselves to orbit the Earth at the same speed at which the Earth rotates? In practice, we're asking where we should be to always stay above the same point on the Earth's surface. The altitude where this happens can be easily calculated, and it is 35,786 kilometers. An object in orbit at this altitude follows Earth's rotation. In fact, this orbit is called a geostationary orbit, used for geostationary satellites that need to stay above a fixed point on Earth. So, a point orbiting at this altitude follows Earth's rotation and appears stationary from the surface. If we built a rigid tower 35,786 kilometers tall, the top of the tower would rotate along with the Earth at exactly the speed of the geostationary orbit. If we climbed to the top of the tower and dropped an object from there, it wouldn't fall to Earth but would remain in orbit exactly at that position. This was precisely the idea imagined by Tsiolkovsky. Naturally, such a tall tower wouldn't just be difficult to build, but it would also need to support its own weight, and we don't know of any material that could withstand such stress. So, Tsiolkovsky's tower idea seems like pure fantasy. However, in 1959, another Russian, Yuri Artsetonov, had a different idea. Why build a tower? Imagine we already have a satellite in geostationary orbit and we lower a cable from there to the Earth, anchoring it to the surface. We could also use a counterweight at a higher altitude to keep the cable under tension, somewhat like in hammer throwing. In this way, we would have a taut cable that extends from Earth to the orbit. At that point, we could send a satellite or even a cabin up along the cable, and we would have a space elevator. This would be very interesting because it would reduce the costs necessary to enter Earth's orbit. Currently, sending a kilogram of mass into space costs tens of thousands of euros, not to mention the risks and difficulties associated with using rockets. With a space elevator, the journey would be much smoother. We could reach orbit in a few hours, and, above all, once the structure is built, it would be reusable. The cost of sending a kilogram into space would drop to just a few hundred euros. All very nice, but could we really do it? Well, the idea of the space cable is not theoretically impossible, and, on a smaller scale, it has already been demonstrated in reality. For example, in the 1990s, a satellite was tethered for several hours to a 20-kilometer-long cable extending from a space shuttle. The experiment, by the way, was a collaboration between NASA and the Italian Space Agency, but it was obviously a much smaller-scale demonstration than that of a real space elevator. Building a cable over 30,000 kilometers long capable of withstanding the necessary tension would be an extremely complicated task, and for many decades it was considered impossible. Today, however, we've made progress with ultra-light and strong materials like graphene or carbon nanotubes, and the possibility has at least been considered. According to estimates from the International Academy of Astronautics, we might have the technology necessary to build such a cable, and therefore a space elevator, in about 20 years. The cost of such an undertaking would be a few billion euros, but of course, the expense would be offset by the reduction in costs to put material into orbit. There are even those who have proposed connecting Earth and the Moon with a cable. The idea might seem even more complicated, but it would have some advantages. The cable would start from the lunar surface and reach near the Earth, not on the surface but near geostationary orbit. The tension it would have to withstand would be lower because the Moon completes a rotation around the Earth in about a month. Additionally, the cable would pass through a point between Earth and the Moon where the gravity of the two celestial bodies cancels out. According to the authors of this study, the cable could even be made with an already existing material. But let's be clear, the space elevator is not a possibility within our reach, at least not in the short term, but it could become one in the future, and then it would certainly be competitive with traditional rockets. For now, the idea of a space elevator has only been applied in science fiction, especially by Arthur Clarke, who made it known to a wide audience both with the 1979 novel, The Fountains of Paradise, which is about the construction of a space elevator, and in the novel, 3001, The Final Odyssey, which concludes the quadrilogy that began with 2001, A Space Odyssey. In this novel, the concept of a space elevator is even more extreme, as Clarke imagines that humanity has built 4 enormous towers at 4 points on the Earth's equator, connected to an orbital ring encircling the entire Earth. Here, we are definitely in the realm of the unrealizable, at least for now. But anyway, could we ever ascend to space simply by pressing a button? Well, someone once asked Clarke exactly when the space elevator would become a reality, and Clarke replied, probably about 50 years after people stop laughing at the idea. Thanks for watching. Leave a like to support us, and subscribe to the channel.